Yours started? There we go. Hello, boys and girls. This is Mrs. Vernetti and Mrs. Farrell, and we are excited to do another Which One Doesn't Belong with You on graphing. I know some of you fifth graders were touching on graphing before we moved to e-learning, but this will be fun to refresh what you have learned, or if you haven't seen it before, let's just look. Which One Doesn't Belong, remember, is 4 pictures, and there's one picture that doesn't match the rest of them, and you can find a reason for every single box. Let's just take a moment to look at the pictures and talk about what we see, and then if you come up with a Which One Doesn't Belong, boys and girls, let somebody know. Mrs. Farrell, what do you see?
Yeah, present it real quick, actually.
Oh, I'm so sorry.
No problem.
So you guys have all just been seeing me, and I'm sitting here staring at graphs. Sorry.
All right, we can start visualizing them.
I'm not going to start over. I'm just going to quick share it with you.
Perfect.
Now,
there we go.
Which one? What do you see?
Okay. So I see 4 different graphs, and they each have a blue line and a red line on them. And they are, all of the lines are going through at least 3 quadrants, some 4. They all, almost all of them seem to be parallel lines.
Mm-hmm. I'm noticing that one is a little bit off of the parallel. Do you know the one that I'm talking about?
Like the bottom left, it's just slightly off of the parallel. Mm-hmm.
Okay, so what would that mean if it's not parallel?
So what do you mean by that?
So parallel lines are lines that would
I see.
touch. So if you kept these lines going on and on, up and down, they would never ever touch. But boys and girls, if you'll notice, this part is a little bit thicker. It looks like you can take 1, 2, 3, 4 steps in between here. And it looks down here, you can only take like 1, 2 steps in between there. So if we were to continue this blue line way down that way and way down that way, eventually down here, they would intersect.
Intersect, yeah. Mm-hmm.
So are you thinking maybe we could say, Mrs. Farrell, that the bottom left doesn't belong with the others because the 2 lines have different slopes, or the 2 lines are not parallel?
Yep, they're not parallel. They will be intersecting. And yes, they do have different slopes as well.
Okay, cool. Let's see if we can figure out which other ones might not belong.
I think the top right does not belong because that is the only graph that has a line passing directly through 0, 0.
Oh, which I think is what they call the origin.
Correct, yes.
Okay, so it is the only one passing through the origin, and I think it's also the only one that doesn't have a line in all 4 quadrants. You mentioned earlier that you saw the lines going through at least 3 of the quadrants. So boys and girls, these lines go through this one just barely, and this one, and this one. Quadrants 1, 2, 3, and 4. Same thing here and same thing here. But here, boys and girls, there is no point of the line that goes through quadrant 3. Okay, so we've got these 2. Let's see if we can figure out these 2. Why don't these 2 belong?
I think, if I'm looking correctly, on the bottom right, what I think is interesting about those lines is that if you look at that blue line, it passes through -2 and 2. Like right, or that perfect triangle right there. And then the bottom line passes through -1 on the y-axis and 1 on the x-axis. So I just noticed that they were passing through the same numbers, only 1 negative, 1 positive. Whereas the other lines, when you take a look at the points they're passing through, the numbers they're passing through, they're not the same numbers, any of them.
That is so observant. And I did not notice that, but when you were talking about that, I realized, Mrs. Farrell, that that's actually going to make what we call an isosceles triangle then. Isosceles triangle is where two of the sides of the triangle are equivalent. So up here, you can see, boys and girls, this big triangle here. One side is 6, the other side is 3. That side is unknown, but 6 and 3 are different distances. And even here, this is like negative a half or a negative a third, and this isn't a whole. Very interesting and observant.
I do like that you can see triangles in all of they're making triangles.
Yeah.
As they pass through.
So now we're just up to this one. And you know what, Mrs. Farrell, we don't have to have a reason why each one doesn't belong. Boys and girls, sometimes you might just find one picture that doesn't belong, and that's okay. You don't always have to find all 4. It's just out there if you're interested in persevering.
Yeah, my only thought for that one, I thought it was the only one that contained a line not passing through a whole number on the axis, but it looked like that's also the case on the bottom left. So I guess is that right? The blue line is not passing through a whole number on the y-axis.
It is. It looks like it is.
Sorry, the one below it, bottom left.
Oh, this one? This is at -2 and 1, and this is at -2 and 4.
Okay. So that is the only one, right?
6 and 3, 0. Man, you are good at this. Which one doesn't belong? So what can I restate what I think I'm hearing?
Mm-hmm.
So what Mrs. Farrell is saying is that all the other lines where they cross the axes happen on one of the whole numbers. But here, this red line is not crossing on the 0 or the -1. It's actually crossing just slightly below 0. So that is a reason why this one wouldn't belong. This is so much fun. Boys and girls, thank you so much for joining us. I'm hoping that you were able to find some reasons why these things didn't belong, and we look forward to joining you again on another day with another set. Keep your brain challenged. Bye-bye.
Have a good day.